Now we're going to do some identity verification. Okay, so I've got an identity up here. We're going to verify that it's true. Really, it's a proof, right? You're going to prove that one side is equal to the other. We talked about this in the past with working with other identities, that you could start on the left side and try to simplify or work things down so that you get the right side. You could start with the right side, try to work things down until you get the left side, or you could work on both sides until you get a common expression on each that they're each equal to. Any of those three approaches will work. I tend to work on the left side, just my personal preference, until I get kind of stuck. And then I work on the right side till I get kind of stuck. Hopefully I get stuck at the same place, and if not, I may have to tweak something, okay? Or I may not end up getting stuck. I may end up, or I may get stuck at the right side. So that would be the ideal situation, okay? So let's try that. Let's start on the left and see if we can get this simplified well. So we start on the left. The obvious starting point is to replace the sine of x plus y and cosine of x minus y with their corresponding identities. Okay, so let's go ahead and try that and see if that helps. So the sine of x plus y, well, let's just replace all the x's with a's, or I'm sorry, all the a's with x's and all the b's with y's. So sine of x plus y, let's go right there. It's going to be sine of x cosine of y plus cosine of x sine of y. All right, so we're just going to move down here, call that the sine of x cosine of y plus the cosine of x sine of y. And then the cosine of x minus y, this one becomes cosine x cosine y plus the sine x sine y. Fascinating. Okay. Well, I see that. That's using the sum and difference identities for sine and cosine. I can be more specific than that, but that's good enough. Now I want to, I gotta somehow change this thing into the right side. It's not super clear how to do that. I could, one thing I could do is maybe skip it and go to the right side and try to simplify that, turn everything into sines and cosines and try to get the other one here. I'm gonna stick with this side though. We'll see. What I do notice is that I've got the same number of terms on top and bottom, right? I've got two terms on top, two terms on top, two terms on the bottom, two terms on the bottom. But notice I've got a weird 1 hanging out here on the one side of the equation that I want to try to get here. And so how would I turn cos x, cos y into 1? Well, I have to divide by itself, really. Maybe that's an option. Let's try it. If I were to divide it by itself, I can't just randomly do that though. That doesn't make sense. I've got to do something mathematically equivalent to the original fraction. I have done this in a previous video where we were deriving the formula for tangents though, where I divide both the top and bottom by the same thing. Remember, if you divide the top and bottom of a fraction by the same amount, it doesn't change the value of the fraction, they're still equal. It just changes what it looks like. So let's strategically or cleverly choose cos x cos y to divide by. Maybe that'll help, okay? Again, we could go down rabbit trails doing this and maybe end up doing something bad that makes it more complicated and doesn't get us to what we want, in which case we just restart, okay? Well, let's go ahead and do that. So I'm going to divide the top and bottom by cos x cos y, and divide here by cos x cos y. When I divide top and bottom of a fraction by something, that's going to distribute to all the terms. So my numerator will become sine x cos y over cos x cos y. Then I have this plus cos x sine y over, and then I have my cos x cos y. All of that is over the denominator. Now the denominator is divided by, again, cos x cos y, and I distribute it to both terms. So we're going to have a cos x cos y over cos x cos y plus sine x sine y over cos x cos y. Huh. Well, this is fascinating. Okay. That's all right. This will work. Let's see what happens. I haven't actually worked through this yet. I'm just making stuff up as I go. I'm seeing something coming up that's not going to get us what we want, but we may have to make an adjustment. That's okay. Okay, so first of all, I see that I can cancel my cos y's. Oops. And I can cancel my cos x's. Why is that not drawing? Let's switch colors here. Cos y's drop off, cos x's drop off, right? Here I've got my cos x's and cos y's both drop off, and over here nothing drops off. Nothing cancels. So now I could maybe rewrite this. Sine x over cos x is actually the tangent of x, right? Sine over cosine is tangent. So this is equal to the tangent of x. Here we've got sine over cosine. Just thinking for a second. Yeah, sine over cosine is the tangent of y. And then here I've got my 1, that's what I wanted. And on the bottom I've got a plus. Now sine over cosine, sine x over cosine x is tangent of x. Sine y over cosine y is tangent of y. So that's tangent x, tangent y. I've got a slight problem. It's simplified, it's not too bad, but it's not cotangents, it's tangents. It looks very similar, but they're not the same. Well, there is a solution. Basically what I did is I chose the wrong thing to divide by. It's not a big deal, it's fixable. So instead of dividing by cos x cos y, it turns out I don't want sine over cosine, I actually want cosine over sine. And so if I were to divide by the sines, instead of the cosines, that would give me the cotangents instead of the tangents. That's okay, I didn't see that coming. So let's do that instead. So I'm going to erase a few things here. I'm going to erase what I divided by, because I'm going to change it. Instead of cos x cos y, I'm going to make it sine x sine y. And maybe some of you caught that as we went. It's not really a mistake necessarily, it's just a something to fix, okay? Which is fine. So then, just an adjustment. So here, I don't want to cancel those off. We're going to change our denominators and not cancel this. And change that denominator. Change that denominator. Change this denominator. Not cancel any of this stuff. We'll leave those in. Okay, good enough. Close enough. All right, so let's go ahead. Take sine x sine y and multiply that through on the bottom. Okay, we'll get sine x sine y. Here's going to be a sine x sine y. Here's a sine x sine y. And here's a sine x sine y. All right. When I do that, It's not going to give us tangents anymore, so I can erase that off. We're going to be canceling off the sines there and the sines there. Nice. This term doesn't cancel, nothing cancels there. But on the second term, everything cancels, right? The sines cancel there, sines y cancel there. And so what we'll be left with is a cosine over, cosine y over sine y, which is tangent of y. So that's tangent of y. Over here, we're going to have cos x over, no, I'm sorry, it's not tangent, it's cotangent. Let's rewrite that properly. That is the cotangent of y. Then I've got plus cosine x over sine x is cotangent of x. All right, now it's looking good. Here I've got cos x over sine x is cotangent x. Here I've got cos y over sine y is cotangent of y. And here everything canceled off, so I get 1 plus 1. Now, I should be writing my rationale here, right? This step that we got was, what do we do? Multiply by, or divide by 1, I guess, because we're dividing top and bottom by the same thing. Divide by 1 and distribute. Okay, divide by 1 and distribute. Okay, so then this step is just using the quotient identities. And then, well, it basically looks the same at this point. We just got to switch our terms around. Everything's added together, so switching things doesn't matter. It's just commutative property of addition. And so we could write this as the cotangent of x plus the cotangent of y all over 1 plus cotangent x times cotangent of y. And again, that's the commutative property of addition, where you can switch things around in addition sign. It doesn't change anything. So I'll write that in. Commutative property of addition. And that basically gets us the exact same thing we have on the other side. Okay, so we're done. Again, there are a variety of ways you could approach this one. I could have actually started on the right side, turned everything into sines and cosines, and converted over to the left side. That probably would have worked. Or we could have started with the left side, got to here, or then went to the right side and probably got to this as well. A variety of things you could do, but I just kind of thought we could get through it that way. Again, it doesn't matter how you get through it as long as you get through it and you have the proper reasoning to go along with each step.